TechInFive.
Python in practice, master real-world projects in 5 minutes. Transform your voice into interactive dialogue with our AI-powered Python app. Follow along as we turn speech into interactive dialogue, step by step. Welcome to our tutorial where we're taking Python development to the next level. Today, we're integrating the interactive dashboard with our OpenAI service and audio service to create an interactive dialogue application. Get ready to transform voice into action and responses into speech, enhancing your Python projects with dynamic audio capabilities. In our previous video, we have created interactive dashboard. Now let's update it for our new application. The constructor sets up the dashboard window, initializes is recording as false, and calls initialize UI method to set up the user interface elements, including the recording button. The initialize UI methods calls add button method to add the recording control button to the UI. The button is labeled start within the button's frame, linked to the toggle recording method, which is executed when the button is clicked. The toggle recording method checks the current recording state. If recording is ongoing whereas recording is true, it calls stop recording to end the recording session. Otherwise, it calls start recording to begin recording. This method acts as the central control point for starting and stopping recordings, allowing the button to dynamically adjust its function based on the application's state. The start recording method activates recording, updates the button label to stop, and displays a message recording started in the text area to inform the user. The stop recording method deactivates recording, resets the button label to start, and outputs a message, recording stopped, to the text area, notifying the user that the recording session has ended. These methods provide a user-friendly interface for starting and stopping audio recordings, with clear indicators for the current state of recording. Now, let's take a look at the updates to the audio service. The audio service is set up to be stateful, allowing dynamic control over the recording process. This includes initializing Pi audio and frame collection, and setting the initial recording state to false. The start recording method initiates the recording process by setting the recording state to true, opening an audio stream for recording, and starting a new thread dedicated to capturing audio frames. The recording method is running in a separate thread. This method continuously captures audio frames from the open stream as long as the recording state is true. The stop recording method marks the end of the recording session. It sets the recording state to false, to cease frame collection, joins the recording thread to ensure all frames are captured, then stops and closes the stream. Finally, it saves the collected frames as a WAV file and terminates the Pi audio session. Let's integrate the audio service within the interactive dashboard. The dashboard start recording method controls the audio recording process. It calls the corresponding method in audio service to begin the recording. Similarly, the stop recording method ends the recording based on user-triggered control. With this integration, we've achieved a user-driven approach to audio capture. As we wrap up this tutorial, let's take a closer look at this final part, demonstrating the practical application of the code we've developed. Upon stopping the recording, we immediately delegate the processing tasks to a separate thread. This ensures our application remains interactive, without freezing or delay. First, the recorded WAV file is converted to an MP3 format. The OpenAI service then transcribes this file, and the resulting text is displayed in the dashboard's text area in the main thread. We then send the transcription to OpenAI service, asking for a concise response. Once received, this response is also displayed in the dashboard. Finally, the AI response is converted back into speech. This synthesized voice is played back, closing the loop from voice to text to AI response, and back to voice again. Let's do a quick demo.
Generate a random number.
7.
Through practical code implementations, we've built an application that leverages Python's capabilities to bridge the gap between human speech and machine interaction. Thank you for following along as we explored the possibilities of modern Python applications.
Stay tuned for more videos on TechInFive.